Welcome to The Explainer. Today, we're diving deep into something huge. Our oceans are on the brink of disaster. But, and this is the important part, there's actually a clear blueprint for their recovery. We're going to look at both the crisis and the cure.
Okay, so let's just dive right in. To really get a handle on the scale of the problem, I want to start with a question, and the answer might surprise you.
Now, you might be thinking deforestation, right? Or maybe all the cities we've built. And yeah, those are huge. But the single biggest disturbance, it's happening right now, completely out of sight, deep beneath the waves. Yep. It's called bottom trawling. It's this practice of dragging these enormous, heavy nets right across the ocean floor. And some scientists say this is without a doubt our single biggest impact on the entire living world.
I mean, just look at this description. They're literally giant underwater bulldozers. The scale of the destruction is just hard to even wrap your head around. Every single year, an area of the seabed, many times larger than all the world's clear-cut forests combined, is just scraped completely clean. We're talking about wiping out ancient habitats in an instant. And it's not just the destruction of the habitat on the seafloor. At the same time, our massive industrial fishing fleets are basically, well, vacuuming the seas. Our technology has gotten so good, so efficient, that it's created a whole other crisis. And here's the consequence of that efficiency. A staggering 90%. That's how many of the ocean's big predatory fish, we're talking tuna, swordfish, marlin, have disappeared in just a little over 50 years. I mean, these are the lions and tigers of the sea, and they're just vanishing. So, all of this has led to this idea of a fish print. It's a lot like a carbon footprint, but for fish. It basically measures how much ocean area it takes to support the amount of fish we eat. And, you guessed it, our global fish print right now is way, way bigger than what the oceans can actually handle. But, the threats aren't just physical. They're not just about bulldozing the seafloor or overfishing. The very same stuff we're putting into the atmosphere is fundamentally changing the chemistry of the water itself. Okay, so here's how it works. It's a pretty simple but devastating chain reaction. First, the ocean soaks up a ton of the extra CO2 from the air. This CO2 then reacts with the water and, well, it forms an acid. This makes the ocean more acidic, and that gobbles up these things called carbonate ions, which are the absolute essential building blocks for anything with a shell or a skeleton. And if you look at the projections, the impact is, well, it's stark. The prediction is that by the year 2100, there just won't be enough of those carbonate building blocks left for coral reefs to grow at all. And that threatens the millions, and I mean millions, of species that call those reefs home. And as if that wasn't enough, there is a second chemical threat piling on top of acidification, these things called dead zones. This whole process actually starts on land with fertilizer from farms. It runs off into rivers and then the ocean, causing these huge explosions of algae. When all that algae dies and sinks, the bacteria that decompose it just suck up all the oxygen in the water, literally suffocating everything else. It creates these huge, lifeless voids in the sea. So, okay, we've got this massive physical destruction, and on top of that, these really serious chemical problems. The science is crystal clear on this stuff, so what gives? Why is it so hard to actually protect our oceans? Well, it's a mix of things, really. For one, all this damage is happening where we can't see it, right? It's the classic out of sight, out of mind problem. Then there's this perception that the ocean is just infinite, that we could never possibly empty it. And maybe the biggest hurdle of all, most of the ocean doesn't belong to any country. It's the Wild West out there. And this creates what's known as the tragedy of the commons. Basically, everyone rushes to take as much as they can for themselves, which leads to a total collapse that ends up hurting everybody. But it's not all doom and gloom. There is hope. We actually have proven real-world strategies for recovery. The key thing to understand, though, is that not all protection is really created equal. And this is a really important distinction. You have something called a Marine Protected Area, or MPA. Sounds good, but often they still allow really destructive stuff like bottom trawling. But then you have marine reserves. These are the real deal. They are true sanctuaries, totally off limits to fishing, mining, you name it. They're places where the ocean can just be left alone to heal. And the results we see from these true reserves, they're absolutely incredible. In just a few years of being fully protected, fish populations, the ones people actually want to catch, they typically double. And it's not just that there are more of them. The fish themselves get bigger, about a third bigger on average. And a bigger fish means a healthier fish that can produce way, way more offspring. In fact, reproduction inside these reserves can triple. Think about that. They basically become these engines of recovery, pumping out so much new life that it spills over and helps repopulate the areas outside the reserve. So, we have this proven solution with these amazing benefits, right? And yet, here's the shocking reality. As of today, less than 2%, actually just 1.2% of our entire ocean is truly safe inside one of these fully protected reserves. So the big question is, how do we scale this up? How do we go from 1.2% to something that can really make a difference? Well, thankfully, there's a plan for that. It's a comprehensive, science-backed strategy called the ecosystem approach. And this isn't just about one thing. It's a whole system approach for all our planet's water. You start by figuring out what's out there and mapping it. Then you identify the most important hotspots and protect them with a global network of reserves. After that, you work on restoring what's already been damaged, like reefs and wetlands. And, crucially, you get local communities involved as partners in protecting their own backyard. Now, what does something like this cost? The legendary biologist E.O. Wilson put a price tag on it. About $30 billion a year. And yeah, that sounds like a massive, impossible number, but let's actually put that into perspective. $30 billion a year works out to be about the same as adding a 1 penny tax to every single cup of coffee sold in the world. 1 penny. Suddenly, what sounds completely insurmountable is actually pretty manageable when you look at it on a global scale. So let's just recap. The science is crystal clear. A detailed plan already exists. The benefits are proven to be incredible, and the cost is well within our reach. That leaves us with just one final question to think about, doesn't it?